Welcome to the channel guys. In this video, I'm quite excited to present you this new project called as Tailor3D. Let me show you some of the assets which has been produced by this project. As you can see on your screen, on the left hand side we had this original image and then prompt was given and we have this 3D render on our screen. So in this video, we are going to install this 3D on our local system and then we will also try to generate some of the 3D assets with the help of it. Now, if you look at the industry scene in 3D at the moment, there are a lot of AI products out there which are showing a lot of promise for creating 3D objects directly from text and images. And that, of course, cut costs in animation and product design. But detailed customization of these 3D assets remain challenging compared to their 2D counterparts. And that is where this project Tailor3D aims to help. It is a new pipeline creating customized 3D assets from editable dual site images and feed forward reconstruction methods. This approach mimics a tailor's local object changes and style transfers. So what it does, first it uses image editing method to edit the front view image. The front view image can be provided or generated from text. And then it uses multi-view diffusion techniques such as 0, 1, 2, 3 to generate the back view of the objects. And then it uses image editing methods to edit the back view image. And then their proposed dual-sided large reconstruction model or LRM to seamlessly combine front and back images and get the customized 3D assets. Each step takes only a few seconds, which enables the user to interactively obtain the 3D objects they desire. And they have also shared some of the experimental results, as I also showed you, that its effectiveness in 3D generative fill and style transfer is quite good, and it provides an efficient solution for 3D asset editing. Now, they have also shared some of the other stuff. Let me quickly minimize it a bit so you'd be able to see it on your screen. So that they have in this screen, they have already edited the front and back images. And as I mentioned earlier, in this particular diagram, they have 3 steps to get the final 3D objects. At the top, step 1, they have used the same image encoder Deno V2 to get the front view and back view image features. And then secondly, the two image features are processed separately using the LoRa triplane transformer, but they share the same front view camera extrinsics. In the step 3, after obtaining two triplanes, they tailor the two triplane features through rotation and viewpoint cross attention to obtain the 3D objects. So looks really good to me, straightforward but quite effective. Some of the other examples from their project page show this 3D generative pattern fill, where you can see that on the left hand side there was a penguin, love heart bow tie, it was filled, and then blue diamond, it changed again, and then bouquet, it has bouquet there, and then you see the final result. And then similarly for the 3D style transfer and fusion, there are some changes which are text based on the Lego model or on the little boy, and as it progresses through the chain, you see that the from the left to right the image is totally changed. Looks really good. Okay, so that is all good. Now before I show you the installation steps and other things, let me give a huge shout out to Mass Compute who are sponsoring the VM and GPU for this video. If you are looking to rent a GPU on affordable prices, I will drop the link to their website in video description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs, so do check them out. Okay, so enough said, let me take you to my terminal where I'm running Ubuntu 22.04 and my GPU card is NVIDIA RTX A6000 with 48 GB of VRAM. Let me clear the screen. First up, let me create a Conda environment with the name of Tailor3D. Let's wait for it to get created. And that is done. Let's also create some of the prerequisites. Let me put the C here with the Conda, which I believe I missed copying. And you don't have to worry about this command. You can get it from their project page. Let's wait for it to get installed. This is going to take a bit of a time because there is a lot of stuff there. Okay, all the prerequisites are done. Now let's git clone the Tailor3D repository. Let's cd into that. And let me clear the screen and show you all the contents of this directory, so we need to run this requirement.txt file with the pip so that it will install everything which is required for this. So let's wait for it. We are almost there as far as installation is concerned. Okay, all the prerequisites are done. Let me clear the screen. Next up, we need to set up some of the environment variables, and this is just to control the generation. For example, we are setting export video true. It is also going to produce the video. You can export the mesh by setting it to true. When you say double-sided is equal to true, it means that Tailor3D uses both front and back view images as input, and if you set it to false, it degenerates it to LRM, which I mentioned in the video previously. And then there is a infer config which is both for training and inference. We are just using it with large, which this is our model name, which is also present on Hugging Face. And then model name and pre-trained model names are there, and they correspond to that open LRM model. And then we are using the example demo assets from their input with the repo which we have just cloned. That is done. So now in order to start generating, all you need to do is to run this command, which is going to launch the inference on the basis of all these parameters which we have just set. And because first time when we will run it, it is also going to download the model. So let me run it. And you see that it is now downloading the model. Let's wait for it to finish. And once it finished downloading, it is going to generate those 3D assets in a folder, and then I will switch over to my GUI and then show you there. Let's wait for it to finish and then we will move over to the GUI. Okay, so it is 100% complete. It's finished. Let me move over to GUI to show you what it generated from the sample. And this is my GUI. If you go to the output folder, you will see that there is something bird.png, and there you go. This is our 3D asset. Looks okay to me, not bad at all. And this is the front of it. That is fine, all good. But anyway, looks really good to me. I think lightweight model, we can run it on 48 GB of VRAM, and then we can create as many 3D assets as we want, I think, and then we can use it in our animation or any production. I don't think so it's bad at all. And also this is the model on Hugging Face which I was referring to. You can download it, and if you just go to its files, you will see that the size is very small and it is quite performant, which I really like about it. That doesn't require much to run. So that's it guys. I hope that you enjoyed it. Let me know what do you think. I'm going to drop the link to this project page in video's description, and you can check out the code which I used, or paper, or even there is a Hugging Face demo if you want to run. Feel free to do so and let me know your thoughts in the comments. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.